In my last video, we talked about finding vertical asymptotes. Today, we're going to talk about horizontal asymptotes and oblique asymptotes using these examples. We are only going to work on finding horizontal asymptotes of rational functions, quotient of two polynomials. I defined that in the last video, and these are the four cases we're going to deal with. When you take calculus, we'll study these four cases in more detail. Today, we're just going to work on applying these cases. Case 1, the degree of the numerator is less than the degree of the denominator. If that is the case, then the horizontal asymptote is the equation y equals 0. In this example, the degree of the numerator is 1 and the degree of the denominator is 2. So n is 1 and m is 2. Our horizontal asymptote is y equals 0. Here's a picture of the graph. There are two vertical asymptotes, and that's where the denominator is equal to 0, and the horizontal asymptote is this horizontal line that's dotted in red. That means when x is really big or really small, the y values on the graph approach 0. Essentially what's happening is the denominator is growing much bigger than the numerator. Here's an example of case 2. The degree of the numerator is 2 and the degree of the denominator is 2. So the horizontal asymptote is the quotient of the leading coefficients, which I defined last time. The leading coefficient in the numerator is 3 and the leading coefficient in the denominator is 2. Here's a picture of the graph. This dotted line here is the line y equals 3/2. This graph also had one vertical asymptote and one hole, which we saw last time. Here's another example of case 2, just because it's so easy. The degree of the numerator is 1 and the degree of the denominator is 1. The horizontal asymptote is y equals, the leading coefficient in the numerator is 9 and the leading coefficient in the denominator is 1. Y equals 9. And here's a picture of that graph. Before we do case 3, which is the hardest, I'm going to jump ahead to case 4, which is probably the easiest. If n is bigger than m plus 1, there's no horizontal asymptote and there's no oblique asymptote. An oblique asymptote is a type of horizontal asymptote. It's just a slanted line rather than a horizontal line. Here we see the degree of the numerator is 9 and the degree of the denominator is 5. And so since 9 is bigger than 6, this graph has no horizontal or oblique asymptotes. Case 3, the degree of the numerator is 1 more than the degree of the denominator. In order to find, in this case, we have an oblique asymptote, and to find the oblique asymptote, we have to do long division. So here we go. I'm going to take x squared minus 4x plus 3 and divide it into x cubed minus 1. Now when I do long division of polynomials, I like to use placeholders for missing terms. So x cubed plus 0x squared plus 0x minus 1. All right, x squared goes into x cubed x times. Then I take x and I multiply it by this whole polynomial and line up like terms underneath like terms. X cubed, then x times negative 4x is negative 4x squared, and then x times 3 is 3x. And now I subtract. Okay, 0x squared minus negative 4x squared is positive 4x squared. And 0x minus 3x is negative 3x. And I bring down the 1. X squared goes into 4x squared positive 4 times. So I go right plus 4 up here. And now I multiply to get 4x squared minus 16x plus 12. And I subtract to get 13x. Whoops, that's a plus 12 here. So negative 1 minus 12 is minus 13. All right, now my long division is done. And what this tells me is the following. that my original fraction can be written as x plus 4 plus the remainder over x squared minus 4x plus 3. This gives me the oblique asymptote, y equals x plus 4. The remainder part goes to 0 as x gets big, so I don't have to worry about that. And my oblique asymptote is y equals x plus 4. Here's a picture of that. The oblique asymptote is this dotted line. Well, that's kind of a dot. It's kind of a line. It's y equals x plus 4. Again, here's the summary. There's 4 cases. Degree of the numerator is less than the degree of the denominator, equal to the degree of the denominator, 1 more than the degree of the denominator, or more than 1 than the degree of the denominator. And just to show you how easy this can be done by inspection, I just want to end with 3 simple examples where we can literally determine the horizontal or oblique asymptotes in our head. So this first one, the degree of the numerator is 0, degree of the denominator is 2, so this has horizontal asymptote y equals 0. This example, the degree of the numerator and the degree of the denominator are equal, so we take the leading coefficients and we get horizontal asymptote y equals negative 1 over 2. And then in this example, the degree of the numerator is 1 more than the degree of the denominator, so this is going to have an oblique asymptote, and it's going to be found by dividing 2x plus 4 into x squared plus 1. Now that you can't really do in your head, you've got to do long division. I'll let you pause the video, give it a shot, and when you're done, you should have gotten y equals 1/2 x minus 1 as the oblique asymptote. That's it. I hope this helps.